Now, class, we will discuss electrostatic boundary conditions. Class, kung mapapansin nyo, nakasulat na yung mga nasa whiteboard kasi kanina I tried recording. Tapos, ano ba yon? Wala palang audio. So, later on ko na lang nalaman. Kaya, hindi ko nabuburahin to. Didiscuss ko na lang. Okay, so, class, kapag meron kang conductor, kunwari ganyan, conductor. Yung electric field dito, sometimes, iba sa electric field dito sa baba. Parang may discontinuity na nangyayari due to the conducting boundary of or whatever boundary na meron kayo. Now, class, consider an infinite plane. Kunwari, yung boundary natin is an infinite plane na may surface charge density na sigma. Now, ito yung infinite plane natin. What we will do is we will make a small Gaussian pillbox. Ito yung Gaussian pillbox natin na merong area A. Ito yung area A niya. Yan. Tapos meron siyang height h na small lang. Small height h lang. So, plus itong Gaussian pillbox natin, tumatagos siya dun sa conductor. Kunwari, ito yung side view ng conductor natin. Yung pillbox natin, paganyan. Next. Okay, class, recall nyo yung electric field ng infinite plane, di ba ganyan lang siya? Pataas. Kunwari, ito yung side view ng infinite plane natin. Ganyan yung itsura ng electric field niya. Then, class, suppose ang n hat natin ay ganito. Pataas. So, ito, negative n hat. Anyway. Sa taas, ang electric field ng due to the conducting plane na may surface charge sigma ay sigma over 2 epsilon naught positive n hat. Positive n hat kasi ito yung taas, di ba? Yung direction niya ganyan. Sa baba naman, ang electric field mo is sigma over 2 epsilon naught pero pababa na. So, negative n hat yan. Now, what we will do is isubtract natin tong dalawang to. So, we have E above, perpendicular. Take note, class, perpendicular, kasi itong electric field na to, normal to the plane sila, di ba? So, perpendicular yung label natin dito. Minus E below, that is, class, ano pala? Ano ba to? Ay, tama lang pala. That is sigma over 2 epsilon naught n hat. Ito yung above. Minus sigma over 2 epsilon naught negative n hat. So, bale, mag-a-add lang yung dalawang components natin. That is sigma over epsilon naught n hat. Bale, class, n hat to. Yung normal component ng electric field is discontinuous by an amount sigma over epsilon naught at the boundary. Class, kunwari, ito yung boundary natin. Ito yung above. Ito yung below. Class, ito, meron siyang amount na, kunwari, E plus sigma over epsilon naught. Dito sa baba, E lang yung value kasi discontinuous siya at the boundary. Now, meron pang isang component. Yun yung ating parallel component. Previously, di ba, meron tayong Gaussian pillbox. Ito naman, gagawa tayo ng closed loop. So, ang closed loop natin ganito. Para siyang rectangle na tinatraverse nyo yung itong length na to. Tapos, tatagos din siya dun sa infinite plane natin. Now, meron siyang length L, tas height h. Tas recall natin that h approaches 0. Kasi class, gusto nating malaman yung electric field just above the plane and just below the plane. Diba? Side view tayo. Gusto natin malaman yung electric field. Just above the plane at saka just below the plane. So, bali yung height natin, approaching 0 yan. Now, also, recall natin that E dot dl that is equal to 0 kapag close path yung tinitignan natin. So, kunin natin class yung E dot dl. So, una, meron tayong apat na sides. 1, 2, 3, 4. Yung unang side, that is E parallel above times L. Yun yung E dot dl sa taas. Tapos, ito naman, that is E perpendicular pero multiplied by H, di ba? So, 0 yon kasi H approaches 0. Tapos, plus E below times L pero negative. Bakit negative? Dahil pag ganun yung path natin. Ay. 'Di ba yung electric field nyo pag ganito? So, bale yung ganyan, electric field nyo pag ganito, pero yung DL nyo, pag ganyan yung direction, magne-negative siya. Na-gets nyo ba? Kasi 'di ba yung una, 'di ba? Yung parallel, yung first term, ito yung L, ito yung DL, ito rin yung E. Dun sa pangalawa, dun sa baba, ito yung E, ito yung parallel. So, bale, nag-negative siya. Kaya may negative na term ka dito. Tapos, ito naman, 0 kasi H approaches 0. So, when simplifying this, we will get E parallel above equals E parallel below. Kasi magka-cancel lang yung L. That means, class, na yung parallel components, continuous sila at the surface. Diba kanina yung perpendicular component discontinuous at the surface? This time, yung parallel components, continuous siya. So, in general, ayan siya. Ito yung conclusion natin kanina. Pero, the electric field equals negative del V. So, negative del V above minus negative del V below. That is sigma over epsilon naught n hat. Or, i-rearrange natin yung mga negative sign. We have del V above minus del V below. That is negative sigma over epsilon naught n hat. Or, class yung mag-n hat dot tayo sa both sides. So, bale, partial V above over partial n minus partial V below over partial n that is equal to negative sigma over epsilon naught. Ay, wala na tong n hat. Bura na yan. Where partial V over partial n, that is n hat dot del V. Class, di ba, n hat that this is partial V above over partial n, tas n hat dotted with this partial V below over partial n, tas n hat dot n hat, magwa 1 lang to. Okay, mas madaling intindihin to. Class, ano yung n? Yan yung normal coordinate nyo. Kunwari, spherical. Ano ang n nyo? N hat yung r hat, diba? So, yung n nyo, yan yung r. So, kung spherical to, partial r yan. Pero in general, gawin nating n. Now, yun lang yung ating electrostatic boundary conditions. And that's it for this lecture.